Hello everyone, myself Anurag Mondal, Assistant Professor of EC Department. Welcome to the series of lecture of network analysis. Today is our first lecture, that is lecture number 1, and what we are going to learn about this session, that is basic terms and components of network, and this is our part number 1. So let's move on. In this particular session, we are going to cover up this following contents. They are motivation behind this particular topic, then voltage and current, what is it? Then comes to Ohm's law. Then we move on to the resistance, power and energy in the resistance. Then what happened if the resistance are in the series combination, and in the series combination we have the voltage dividing rule or voltage division rule. Next we are going to cover up the parallel combination of the resistances, and whenever the parallel combination comes, then the current division rule is present over there. So we are going to cover up this following contents. So let's move on. Okay, so what is the motivation behind this particular session? Okay, first of all, what happened? We have this kind of circuit, or we have this kind of network, and whenever this particular kind of network is in front of us, then the first basic question that come in our mind, that is what is V, what is I, because we start looking at the circuitry from this part. So the V first come first. V is nothing but voltage. So if we don't know about the behavior of the voltage and what voltage do, we are not able to understand what the network do. So we have to know about the voltage. What is it? Why it is required in this particular network or circuitry? Then if the voltage is there, obviously the current also be there, as we know this thing from the childhood, that whenever there is a voltage source, then there is a current. So we have to know what is the current, what is the logic behind it, why the particular current is flowing through that circuitry, how much current it will flow, and what is the characteristics of the current, what is the dependency of current with time. So this kind of behavior we need to know. If we don't know this kind of behavior, then we are not able to learn about the networks and what the network do. So this particular voltage and the current is much more needed. Now the second thing is, what are R, L and C? Here it is R, here it is L, R and 2C. These are nothing else but resistance. L stands for inductor and C stands for capacitor. But what these components are, what is resistance, what is capacitor, what is its behavior in the circuitry, why, if the inductor or capacitor or resistance is connected in the circuitry, what kind of nature of the current within this particular circuit, why these components are connected. We have to know this thing. we have to know the behavior of each and every component. If we don't know the behavior of each and every component, that is the R, L and C, we are not able to know the overall behavior of the network. And if we don't know the overall behavior of the network, we can't design any kind of practical projects. As we know, or as we say in the introduction video, that if you don't have that kind of knowledge, that why that particular circuitry is present over here, why the connection is there, what is the value of that particular component, we doesn't not able to solve any kind of circuit. And at the end, what is the dependency with the time for this R, L and C. So that is why today's session is much more important. In the today's session, we will learn about this basic terms. If you got these basic terms, this total series of lecture is going to be very easy. So let's move on. Voltage and current. First is current. Current is nothing but the movement of electrons through a conductor. Now, when that flow of electrons is there, look at this image. We have some component that is in terms of positive, and we have some component that that having a negative sign. Means here it is having some higher potential, higher thing. Positive means already all of we know positive means high. All of we know negative means low. So this particular body having something high value, this particular body having something low value. And whenever there is some high and the low value, then and then if some conductor is connected between this particular two bodies, a current will flow through this conductor, or electrons are flowing through this conductor. Now keep it in mind, the electron is always flow from the negative or the lower to higher. But what we take the current convention? Current convention is the opposite direction of the electron flow. That is why current is flowing from the higher to lower. Now, we are talking about higher and lower. What the higher is? Higher is nothing but the higher potential, and lower is nothing but the lower potential. So whenever two bodies are there and two bodies having some difference in potential, one having higher potential, another having lower potential, then and then a current will flow or electron will flow. And if there is a flow of electron, then and then current will arise. So we can say the electron is nothing but the charge. So rate of charge or rate of flowing of charge is equivalent to I. So Q stands for charge, that is electrons, and rate of charge or flow of charge is called the current. Next, come to the next most important thing, that is the voltage. Without voltage, we have nothing, because here it is higher potential, positive means. Negative means lower potential. Now, what is higher potential? Higher potential means the higher potential voltage. Lower potential means lower potential voltage. So obviously, there should be a potential drop higher to lower, then only the current flows, and or then only the electron flows. So the definition is the electric pressure that cause a flow of current, that is called the wedge voltage, and it is also called the EMF, stands for electromotive force. So whenever there is a voltage drop across that two body and that two body is connected with a wire, then and then the current will flow due to the flow of electron. That is the basic thing. Move on to the next basic things, that is the Ohm's law. Now everyone's know what is Ohm's law. Ohm's law states that the current flowing through a resistance is directly proportional to the difference between its end. Little bit confusing in the statement. Let me show you what this particular statement will tell you. This particular statement will tell you that the voltage is totally proportional to the current. That how much voltage difference between two bodies are there, that much of current will flow across that two bodies. Okay, now what happened here, it is the proportional sign, so we have to make it equal sign. So whenever we are moving towards the equal sign, one proportional constant should be there. That proportional constant is nothing but the resistance. So we can say in this way that the resistance proportional constant is over here. Okay, so we can say that current is equal to voltage upon resistance from this particular equation, that if V equals to I into R, so obviously I should be equals to V upon R. Okay, so what the statement says, again I'm saying that Ohm's law states that the current flowing through a resistance, okay, is directly proportional to the potential difference between it. Hence, let me show you the image. We have a body at point A, another body point B. If both the body having some difference in voltage, that is the VA and VB, and if the VA having the higher potential voltage than the VB, then and then a current will flow from the higher potential voltage to the lower potential voltage, that is I. From the Ohm's law, we can say V is proportional to I. So whatever the voltage difference between the two bodies, that much of proportional current will flow across these two bodies. And if the proportional sign is there, we have already tell you that one resistance will come. Resistance is nothing but the proportional constant. Now where the resistance will place, that place between the conductor. This particular resistance is nothing but the property of the conductor. We will just tell you what is the resistance. Now here same thing, two bodies, one having higher potential, one having lower potential. So VA having higher potential, VB having the lower potential, and because of this difference in potential voltages, we have the current from VA to VB. That current will flow through the resistance. Okay, so now let's move on. Comes to resistance. Resistance is the opposition of flow of current through the conductor. It is the property of a conductor. Now, what particular this statement says? Look at the previous slide. Here I have I is equal to V upon R. Now, look at this equation. If R will increase, means denominator will increase, keeping the V as constant, then obviously I become decreases, because overall V upon R effect become decrease. Okay, and already we know because of V I will come. So obviously V should be constant over there. If R changes, then and then I changes. If R increases, I decreases, and if R decreases, then I will increase. R is what? The resistance that is in between the conductor. So if the resistance of the conductor increases, then and then the current flow, low amount of current will flow between the two bodies having the same potential. Okay, difference. But if we having the same potential difference and the lower amount of resistance, then and then a large amount of current will flow, or larger amount of current will flow. That is written over here. The resistance is opposition of the flow of current through the conductor, and it is also says that it is the property of the conductor. Now what is the resistance? Look at this. We just take a part of the conductor that is connected that two body. Okay, and this conductor, that's part of conductor, we have a length of L, we have a cross sectional area, that is the A. Now we know that, or we can say that R resistance is proportional to L upon A. Means, look at this. This particular part of the conductor having the length L, and R is proportional to length. Means, if we have the larger length, then and then R also become increases. If the L increases, R will increase. But contradictory, we have the cross sectional area, and that is A. We have R inversely proportional to A. Means if the A increases, then and then R will decrease, and if the A decreases, R will increase. Okay, so R will depend upon this L, A and A. But this is a proportional sign. Again, that proportional sign should be replaced by the equal sign. And whenever when it is possible when we replace with the help of a proportional constant. Now here the proportional constant is rho. Rho means resistivity. Now this resistivity is depend upon the temperature. If the temperature changes, the resistivity of the conductor will also change. Okay, and if the resistivity change, then and then the overall R value is also changed for the conductor. So whenever we are going to study about the resistance, or we want to measure some resistance of the conductor, then and then it should be kept it in mind that the temperature should be constant. Next, the power. Power is what? When the electrical current flows through a conducting material, work done in moving the electrons. So electron will flow through the conductor in terms of current flow. Okay, so to flow that electron, how much work will done, how much work is done, that much of work is nothing but the power, or we can say ability to doing work is power. So to move a electron from one place to another, what amount of work we can do, that work is defined with the word power. What P equal to? P equal to, we can say the equation that is the V into I, where V is equal to I into R. So P is also written as the I square R, and P is also written as the V square upon R. Okay, so ability to do the work, ability to move electrons from one place to another place. That work we have done to move the electron from one place to another place, that is power. Move on to the next thing, that is the energy. Energy consumed is expressed as watt hour or kilowatt hour. That is the units. The power dissipated in the resistor is converted to the heat, which is given by energy should be equals to power into time. So how much power is in a particular time we consume, that is called the energy. Okay, so we can say in a simple way, that is the W equal to P into T. So what happened, normally within the resistor, whatever the power power or energy consumed, that is in terms of heat. And this is the generalized equation of the energy. But if we talk in terms of the voltage, resistance and current, we have this kind of equation, that is equals to 0 to T. From 0 to T amount of time, what amount of power will consume, that is called the energy. So 0 to I, VI into dt. Same way, we just replace this V with I into R into I. So we have nothing but the I square R into T. So the equation of energy in terms of current resistance, that is I square into R into T. Mother means the duration of time between which we are going to do some work, that is called the energy. Okay, or as we already mentioned, that within the resistor, that particular energy is consumed in terms of heat. Let's move on. Series combination of resistance. When a number of resistances are connected in the series, then what will be the equivalent resistance? Equivalent resistance is nothing but the R1, R2, R3 and dot 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 Rn. Means if the n number of resistance is connected in series, then what will be the overall resistance or the equivalent resistance? That is nothing but the addition of all the single resistances. Next, from the series of resistance, we have the voltage division rule. Okay, and what is the voltage division rule? Here it is a series connection between the R1 and R2. So obviously equivalent resistance become R1 plus R2. And if the overall voltage is applied, that is V, we can say that the voltage across R1 become V1 and voltage across R2 become V2. Means whenever the resistance are in the series, the voltage will divide. First thing. Second thing, whatever the current will flow due to these two resistance and application of this particular voltage V, that is I, that I is constant across these two resistance. So we should keep it in mind that whenever the resistance are in the series, the current will never divide, only voltage divides. So what the voltage division rule is, we have to find out what is the value of V1 in terms of the R1, R2, I and V. That we have to find out. Now, first of all, we have to know what is the value of I. That I value, that is coming from the Ohm's law, that is the V upon R. Okay, what is the R over here? These two are in the series connection. So what will be the equivalent resistance? That is the R1 plus R2. Now, by applying Ohm's law, we can say V1 should be equals to I into R1. So, what is the value of I? Just V upon R1 plus R2. We just replace this thing. Same way for V2, we just replace the V upon R1 plus R2 multiply R2. So, what is the voltage of V1? That is the current flowing across this R1, that is the V upon R1 plus R2 multiply this resistance. So that is the voltage divide rule, or the voltage across each and every resistance. Move on to the parallel combination of the resistance. Now, resistance are said to be connected in parallel when the same voltage is applied across each resistance. However, the current through each parallel branches will be different. Now, for an example, I just take two resistances, and two resistances are in the parallel combination. We can say the equivalent resistance of that parallel combinations are the multiplication of that two resistance R1 and R2, and in the denominator the addition of that two resistance. That is the simple formula. That is the multiplication of two resistance divided by the addition of that two resistance. Now, as the statement comes here, the current through each and every parallel resistance will be different. Means current will divide, but the voltage must be same. Here it is also written that the voltage is applied across that two resistance, same voltage. So in this circuitry, same voltage, okay, but this R1 or R2 in the parallel combination, the ending point and the starting point are the same. That is the parallel combination denotion. Okay, so V is applied across the R1 and R2 both, and in the parallel combination the current that I will divide, that is the I1 and I2, but voltage across R1 and R2 both are the same. That is why the current division rule in the parallel combination or parallel circuit. Okay, so now I1 we can say what? V upon R1, or same way from the Ohm's law, another way we can say the I2 equals to V upon R2. So we can say, and what is the overall current? That is the V upon equivalent resistance. Equivalent resistance of what? R1, parallel combination of R1 and R2. That is the R1 R2 upon R1 plus R2. Next, if we talk about the I1 or finding the I1, what we will do? V divided by R1. Now V we can replace with I into I equivalent, and we just replace this I with the help of this particular equation. We have ultimate equation like I, that is the overall current in this particular combination, into R2 upon R1 plus R2. R2 means what? Here it is R2. And in the denominator R1 plus R2. So in easy way we can say what? That the overall current I1 should be equals to overall current multiply with the opposite branch resistance, that is the R2, divided by R1 plus R2. Same way we can say that I2 should be equals to overall resistance I multiply into opposite resistance R1 divided by R1 plus R2. Let's see, here it is. After doing all the things, we have the equation I into R1, that is the opposite opposite branch resistance divided by R1 plus R2. Okay, so that is the simple formula. So what is our outcome in this session? What we learned? We have learned about the voltage and the current. Okay, we have learned about the current. Whenever the electron flows, then the current flows, and the current will flow from the higher potential to the lower potential. Okay, positive body and the negative body. And also we know about the Ohm's law, because whenever there is a voltage drop, the proportional amount of current will flow across that particular two body. Then we learn about the resistance, the power and energy within the resistance. Then we talk about the series and the parallel combination of resistance and what will be the equivalent resistance of that. And whenever the series and parallel combination resistance will come, then the voltage division rule and current division rule is also there. So this much of thing we have learned in this particular session. So that's all about today. But we have most interesting thing, that is the quizzes. This is the first question. Now what is the question over here? This is our circuit, and within the circuit we have to find out the current supplied by this 12-volt battery. Then we have the question, what will be the equivalent resistance between the point P and Q? Here it is the P and here it is the Q. Then at the end we have to find out what will be the equivalent resistance between the P and Q. These are the three quizzes or three questions that you have to solve, and you can discuss about this question in our online live lectures. So that's all about today's session. Thank you.